Thanks all for coming out. My name is Ryan Mermall. I see some familiar faces, a lot of new faces as well. I'm actually out of Chicagoland, so not from the SoCal area, but I'm happy to be here on behalf of Mastercam. I recently came over to Mastercam with the acquisition of Mastercam Probing, or formerly known as CIMCO Probing. So I'm a sales engineer now here at Mastercam, heading up kind of that project and product, and then also still covering a lot of the other CIMCO related products, again, here at Mastercam. So today my portion of it is going to be going over the Mastercam simulation options. Obviously you guys know the ones that come within Mastercam, but may or may not be familiar with the ones that could be an add-in to your software in order to enhance your programming, make you a more efficient programmer using some of the newer technologies such as GPU processing of simulation, things like that. We'll do a quick side-by-side comparison, answer any questions on that, and then we'll move into the Mastercam probing side as well. So just to kind of recap and cover, some of the standard options of what you're going to be familiar with within Mastercam as far as simulation is going to be your backplot, your verify, and your machine simulation. Your backplot is obviously going to give you a simple view of backplotting the actual code itself. There's no real setup involved, with it. It's just going to go ahead and show it right there on your screen. It's not going to show you any stock, and it's also not going to do any gouge checking, right? So that's where then we would jump into like a verify. That way we can bring in our stock, we can bring in our fixturing. There's a little bit of setup involved as far as defining those things, but it's also not going to be 100% accurate as far as like approach and retract moves, just because it's going off of the toolpath NCI data, not the G code. We could also then take that to kind of their top level or the final step as far as the machine simulation, and that's where we can actually bring in the machine models. You can occasionally tie it to the post processor, get a better accurate representation of what that is, because now we're going to be defining axis limits. We again bring in the CAD models of the actual CNC machine, but again, it's still based on the NCI and the post processor. Some of the, I'm missing a couple slides, but that's okay. Oh, interesting. Oh, it's hidden. Let me unhide that slide. So again, that's going to be on the Mastercam side. On the CIMCO side, we also have similar to that as well, one called CIMCO Verify. The CIMCO Verify is going to be directly loaded up in Mastercam. I would say it's comparable or equivalent to the Mastercam Verify. The difference is that we are using the CIMCO technology or the kernel from the simulation of what we have in our CIMCO Edit that they developed in-house from the ground up. The big thing there is we leverage the new technology of your graphics card, so GPU processing, and is 10 times at least faster than going off of your CPU instead. So to kind of give you an idea, number one, as you can see, a CIMCO Verify, again, equivalent to the Mastercam Verify. They do offer that with a machine simulation, so again, we can tie in the machine models and do accurate collision checking as part of that. And some of the other options then could actually be getting into the true G-code simulation. So that's going to be like CIMCO Editor, which is more of a backplotter, but specifically for G-code simulation. And then, of course, machine simulation within CIMCO Editor, again, tying in the machine models, axis limit checking, collision detection, things of that nature. So they offer a lot of different varieties as far as where specifically you would want to use that simulation. A lot of people say, well, I'm running a 3-axis part. In my opinion, for the cost of it, if you break a couple tools, right, you've paid for the product right there as it is. Again, to kind of give you an idea as far as what we're talking about, specifically using the GPU for processing, you guys may recognize this part of the goalie mask. This is something one of the older applications engineers at Mastercam did probably a year or two back. In this video, we'll just start rolling it here. We'll just do a quick time difference. And notice we're only bringing in maybe 20 operations as part of it. Okay, so doing some finishing on here. So obviously we're already at a minute, not even loaded up, right? Then we, start playing and it's still loading up in the background as part of that. And then as you can see, in about 6 minutes and 48 seconds, we're finally finished with that grouping of toolpaths as part of that. Now, I'll speak for myself, but I'm not a guy that can program and get it all on the right, first shot. I'm usually going in to verify 20, 30, 40 times in order to make revisions of that, tweak something here and tweak something there, right, and dial everything in. So 6 minutes, 48 seconds. If we look at that within the CIMCO Verify side, again, leveraging your GPU and processing, so we load everything up. We're going to go ahead and play that through. And what you'll notice is that we're at about 21 seconds in order to do that, right? So drastic time savings is part of it. Now, if you're going in 20, 30, 40 times, you're not spending all day in verification where you actually could be programming maybe another part, feeding the floor, whatever it may be, as part of it. So again, talking about, what can you do or what tools can make you a more efficient programmer, right? This would be one of those that I would strongly suggest maybe taking a look at as well. Okay. Any particular questions on the simulation or the verify that CIMCO has to offer? And even though I'm here with Mastercam, CAD-CAM Consulting is obviously a distributor of CIMCO products. And that leads into my Mastercam probing presentation or section of it. As I used to work for CIMCO, Mastercam Probing was formerly known as CIMCO Probing, and Mastercam acquired the technology or that business in March of this year. So part of that transition is I came over to Mastercam, but I'm still involved with the CIMCO products, overall. So quickly, we'll just go through maybe some of the changes from CIMCO Probing to Mastercam Probing. We'll go over quickly, what is probing, why to use it, when can you probe, and then perhaps even go through a little live demonstration as far as what that looks like. So like I said, CIMCO Probing, has anyone heard of CIMCO Probing in the past? I know there's a couple customers in here, yep. And out of curiosity, for a show of hands, who has probes on their machines? Okay, so a lot more hands, right? So CIMCO Probing was acquired by Mastercam earlier this year in March. It is being rebranded as Mastercam Probing. One of the biggest differences that is nice about the acquisition is now it's fully within Mastercam, so that means for licensing, but it also means for additional development resources. I hate to admit it, but with CIMCO Probing, there was 3 of us. There was myself in the US, 2 guys in Denmark, and that was it. So needless to say, there was a lot of long hours, late nights, right, in order to support, US, Canada, things like that. Obviously with Mastercam, right, I think there's like 375 people overall, in Mastercam corporate, not even to talk about like Sandvik as a backing and things like that, of course, too. Okay, so a lot of different resources to that. For instance, Mastercam has their own, language group, right, as far as translations. They have their own development teams. They have, for tooling, right? So everything is definitely cross-organization where they have a ton of different resources that can be put into there in order to further develop the product. The other thing is it's going to be aligning to the Mastercam licensing structure. So part of that, if you did already have a CIMCO Probing license, that did get integrated into Mastercam as part of it and tied to your license as that as well. It is going to be working with 2025 Update 7 or 2026. We'll then reference the Mastercam Probing licensing as part of it. It is still being developed as an add-on product, right? And so what that really means is that probing is going to be external to the Mastercam build itself. The nice thing about that, and I think one of the benefits that we had at CIMCO being external is that we developed on our own schedule, which means that we can then get releases out quicker, to the users, right? Whether that be a bug fix, whether that be an enhancement. Again, we can do all that externally and release on our own schedule. And then at that point, the main build of 2026, 2026 R2, right? Those can be pushed in, as needed as well. So for those that maybe aren't familiar as far as what probing is, obviously there's going to be a spindle probe and a table probe. The spindle probe itself is just going ahead and capturing a position. There's going to be macro programs on the CNC control that are doing all the calculations as part of that. There's obviously the body of the probe with the sensors and everything in it, and then of course the stylus, which is actually making contact as part of it. So a couple of reasons on why to use Mastercam probing is we're going to go ahead and program it directly off the same model that you're using for tool pathing, making the programming of the probe a natural part of the process. That way it's going to be put in as a standard operation. You would be able to run it through any of your simulation options, post out as part of your main file, and now you have a single ready-to-go file for the shop floor as part of it. The Mastercam probing does use we'll pick on Renishaw for instance, because they're quite popular here in the States. We do reference the Inspection Plus macros, so those are going to be the standard like 9800 series macros that, if you are using a probe, either through like a VPS or by hand, you'd be recognizing and familiar with those. And then of course we do support more than just Renishaw, so whether that be Bloom, there's Marpos, a ton of different options out there that obviously would be able to be supported, along with any custom cycles can be definitely built out as well using the core technology. So a couple places on maybe where you can incorporate your probing into your manufacturing process would certainly be before machining, and I think a lot of people do that already in order to set work offsets, align the stock to the machine itself. You could also use the probe initially to check for a part orientation, right? Make sure that it's not, flipped 90 degrees. Maybe there's a locating hole or something like that. Again, we could use the probe in different forms or fashions in order to check those kinds of things. You could obviously then start incorporating the probing in during machining, right? So that could be to check a feature, maybe do a if-then conditions as we refer to it as, which is going to do a cut, measure, cut scenario. But also checking for broken tools, again, before spending more time cutting, the actual part itself. And then finally, right, we could do post-machining, which is then going to be maybe if there's a hard feature to reach, we could check it within the machine, all without pulling that part out, putting it on a granite plate, whatever case may be. And along with getting, live data or live results out from the machine using like a deep print kind of statement. So to give you guys an idea here, if I pop up Mastercam, you'll notice I have, obviously this part, I'll go ahead and maybe get rid of these operations to start. So with Mastercam being an add-in, right, we would have our own dedicated tab here, and the cycle probing icon is going to be the main option that would be used. Now, what we're doing here is we are dividing up the standard Renishaw inspection routines into these 4 different categories. So alignment is going to be aligning any rotary axes to the part, or the part to the rotary axis itself, and putting that into the work-off register of an A, B, or C axis. Workpiece datum, its only or primary job is to set a 0 point on the part itself, so that would be kind of our before machining aspect. And then workpiece inspection is using those same exact cycles, but now we're just using it a different way. Instead of setting a work offset with an S value, now we're going ahead and checking that part. We have data as part of it. We can give it tolerances. That's where those if-then conditions can come into play. A number of different options there we could do with it. Along with then probe detection. So probe detection is kind of unique in the sense where when the probe is moving around, we have a protected safety move. And that way if the stylus were to be tripped, we're going to stop the machine without crashing it. And so you could check a part orientation. You could check to see if a toe clamp's been removed, before sending a cutter through. Again, a number of different ways you could do that in order to achieve more automation and less hands-on with the operator. So for instance, for setting a work offset on something like this, let's just say I wanted to set like an X and Y, we could go workpiece datum, kind of do a process of elimination, figure out what the best routine would be here. Maybe we'd settle on like a rectangle outside feature. Within there, right, we obviously have a probe. Probe just needs to be defined as a lollipop mill. In this case, right, we do have the full profile defined of the actual probe itself. And then because we're within Mastercam, we're going to want to be associated to geometry, right? So that way if the geometry ever moves, grows, shrinks, anything like that, we're tied to it. We just simply need to regenerate the operation and we're back off to the races again. So depending on the cycle, right, we're going to have different geometry selection options. In this case, maybe I'll say from stock, right? My stock is set up here, so that's good. We pull what we can off of that. So X0, Y0 is where it's at. We have my width and my height, and then now it's just up to me to say, okay, this is how deep we want to go. Maybe this is how much we want to stand off the surface, and maybe this is my clearance height. Again, because we're within Mastercam, and for those that would recognize these being yellow fields, you can certainly right-click in as part of there, and then again, grab geometry or information off of the graphics window, itself, getting a live updated feedback as part of it. But in this case, since we are setting a work offset, I can maybe give it a little over travel distance, tell it my work offset we need to set, and then we're good to go. From that point, it's now a valid operation. We could run it through graphics if needed. And then ultimately, if we post out, you'll see that we have the easily recognizable Inspection Plus code. That you're most likely used to seeing, right? So probe on commands are 9832 for, this is posting out for a FANUC. 9832 probe on, protected safety moves are 9810, 9812 is our width cycle in X, width cycle in Y, up out of the way, turn the probe off at that point, okay? So again, just a simple kind of operation, but everything follows that same workflow. For instance, maybe there was this center bore, maybe it's a critical feature, tight tolerance, right? I'd be able to do the same thing in process where we can actually go in, we set it up like a normal operation using the inspection cycle, right? Measuring that particular bore. In this one I am writing the diameter, the actual diameter, into a pound variable, so that way I can look at the macro variables page. Some controls will display it in somewhere on the main page, right? So the different options there you could certainly do. But in this one in particular, I'm also leveraging our if-then conditions. So Mastercam Probing considers that feature to be in one of these three conditions. It could either be scrap, which in this case being a bore would mean there's too much material removed and there's no salvaging it. It needs to be remachined, so in this case it'd be too small, or it's within tolerance. And so we can tell it if it's scrap, maybe I want to do a manual entry. Maybe I want to do, probably don't want to continue on making a bad part, but maybe I want to do an M0 to stop it, go to the end of file. Like I said, I personally like to do a manual entry. If I'm on a FANUC style control, I'll do like a pound 3000 equals 1, give it a custom alarm message, that way the operator knows why the machine's stopping. If it needs to be remachined, if I needed to babysit it, maybe I do a similar approach and again stop the machine, and you guys can determine what do you want to do with it from that point. But otherwise, maybe you want to go back to the operation that we finished that at, and maybe we want to recut that. That's where we could say go to an operation. We'd be able to select that operation out of the list. I can see it was a contour, finish center bore is my operation comment, and now we're going to recut and rerun that particular part. If we're within tolerance, then we'll continue on like normal. In addition to that, you'd be able to use the Renishaw macros that allow you to do a tool offset update. You can give it a tolerance of when it's going to be met. If it is out of tolerance, it can obviously update the tool. You can tell it a percent of deviation, but maybe not to exceed a value, right? All of those controls are going to be built into the Renishaw macro, and that makes it very easy to put in that data right here into the Mastercam window. The nice thing is again, if we take those and we post it out, we handle all the formatting for you. So if we actually look at the code this time, there it goes. What you'll notice is that we're automatically putting an insertion label, right, a sequence number, so that way we can have a point to restart to. Obviously, the first time we're just reading, top down, so we just cut the feature. We're coming in doing the actual probing itself. You'll notice there's a couple extra inputs here to the macro. Here's where I'm actually copying in that data, right? So Renishaw is writing into these common variables, and those are being overwritten per probing cycle. So by copying in that to a user-defined variable, it's going to stay there so you can reference that data later, use it in the calculation, whatever you may need to do. But then what you'll notice is we have these if-then conditions, right? So we're referencing the pound 143 variable, which on a FANUC is going to be the deviation based on the diameter of that bore. And so we're saying if that deviation is greater than or less than the tolerance I gave it, now we're sending it to a different label, right? We're actually scrapping it out. Maybe we need to do the remachine and rerunning and cutting it again. Otherwise, we're within tolerance and continuing on like normal. So again, that's all going to be output for you with minimal, setup within the GUI. The last thing to kind of highlight on the probing is, again, using it post-machining. Again, we can use it to check features, again, all within the machine without removing it from the fixturing or whatever the work holding may be. We can obviously output that data into different reports, but one thing that could also be done is using our probing inspect. And probing inspect actually will take the results from the machine using like a dprint statement, and that allows us to actually import it back into the Mastercam file and save it natively in the file itself. That way, if we wanted to see where things are at, we can overlay to a view like this and see that data. We can see that this particular feature, this concave feature, was actually overcut. My tolerance was 3 thou, so that measured at 3 thou 2/10, right, as part of it. The other ones are within, and that's why I'm seeing the color difference there. In addition to that, we could obviously create a probing, report, right, and then that way you have some type of information to go along, with it. So again, you can certainly reference the probing and incorporate it into your program, again, in a number of different ways and areas to better the workflow. Any particular questions?
So this is an add-on?
It is an add-on. Okay. Yep.
If we already purchased the CIMCO Probing,
Yep.
will it be an automatic add-on?
Correct. So
2026 or?
2025 update 7 or 2026. Yep. So it would have been the data basically would have been merged in already to your HASP, NetHASP, Weeboo Networkable Weeboo license, and so then you would most likely just need to update your license. Sometimes that's like a deactivate, reactivate, more or less. You could go through the help menus in other instances to I forget where it is, but you can go ahead and check for license updates. Check for updates. Show new licensing updates. Right, you could do it that way as well if it's hosted locally. So if anyone's running a HASP, right, those are the purple dongles. That one does require what's called an ACC file, and that's something that CAD-CAM would be able to provide if you guys need it. So. But then at that point, right, just 2025 update 7 or Mastercam 2026, we'll be able to know how to read that information correctly. Yep.
We have a question on here.
Yes.
How to set a probing cycle in B90? That makes sense?
In B90, so I'm assuming they're referring to a rotation as, in the part itself. So if the machine were to be a 4 or 5 axis, then we could do like a 3+2. So similar to a toolpath, right? You would create at that tilted plane. You would do the same thing with the probing. You could have your WCS, we'll say top for this example, and then your tool and construction plane at that particular skewed plane, which will output the rotation. And then obviously it's going to be probing from that point. So no real difference there. So.
Is the post-processor integrated into your existing Mastercam, or
Yeah, so the post processor, for those that aren't running probing yet, there are some post modifications that do need to be implemented into the post processor. They're fairly simple changes, so but they just need to be done in there. And part of that is going to be defining what probe and what control type it's going to be on. So whether it's a Renishaw on an Akuma control, a Haas, a Fanuc, right, Matsura with their PQI macros. So that's where we define those different portions there as part of it. So I would say the best bet would be just reaching out if needed and sending them a zip to go on that. So and then also like the mill default post in 2026 does contain that logic already. So yep. Yes, sir.
Are there any plans for you guys to move this into the mill-turn product?
So
I've begged for it for years.
yeah, so it's kind of a touchy subject, and the reason being is because it's not technically supported. At CIMCO, we did, to say lightly, we did workarounds in order to get a working solution, but it certainly wasn't, the most ideal way to do it either. So I know that plans are, and I think Yvonne could probably speak to this too, but I know there are plans to redevelop the, probing for mill turn and further into lathe, things like that. So, yep. Yep.
Did you support Hindi control?
Yeah, so we do support Heidenhains. That was the question was, do we support Heidenhain controls? So yes, we do support Heidenhain. We do support Siemens. For Siemens and Heidenhain both, we do reference their native probing cycles, right? And then that's all going to be defined again within the post processor, where we'd be able to tell it, okay, this is my Heidenhain, and we can see all their standard probing cycles here. If it's a Siemens control, right, we would define that as well. Which then are the standard cycle, and then 9, something, right, would be part of that too. We do have a number of other native controls. Akuma has their own native probing macros that we do have support for. Makino, I think, does as well, right? So a number of different ones there. So. Any other questions? Yes, sir.
One of your competitors, CAM competitors, offers a best fit solution. Do you
Okay.
guys offer anything like that in the center?
So we're not doing any best fitting, as part of it, at least natively connected to, the CNC machine is part of that. So, I guess it would just depend on what you're, going after as part of it. So, I have had customers take the data from the machine, bring it back into Mastercam, align it to those kind of points, but it's not a live connection, to the machine to feedback data. So, yep. Yes, sir.
Training.
Yep. So training-wise, there's a number of different options, whether, Mastercam or CAD-CAM consulting. I will say prior to CIMCO even, I did work for a reseller as part of that and had to, try to implement some of the other probing solutions, before that point. So what I will say to that too is if you're familiar with your probe and actively using it, you kind of already know that. You kind of already know Mastercam, right? And so now it's just learning, a sliver as far as how do we merge the two together. A nice thing too that works well, I feel, is that even within the cycles, if we look at some of the options here, you'll see like Q is an over travel distance. If you're maybe looking at your CNC programs that you've written by hand, you can see, okay, Q needs to be 125, right? And it's easily, you can match that over into your Mastercam program. We also have like a preview window, in order to see what, those changes are live as part of that. But yeah, that could either be usually remote, on-site, in classroom, a number of different options depending on, where each user is at in the process. So, but being that we are referencing, in this case, like the standard Renishaw macros, right? One of my biggest things I leverage in my trainings is going to be the Renishaw Inspection Plus manual, just because that's where you can actually see where are the variables being written into and why are we, referencing up, like I said, a pound 143, what is a Q, what is a 9814, and we can make, clear understandings as far as what that's doing, so. Yes, sir.
What is the cost for the add-on for that?
So the software itself is a $3,000 add-on, and then it'd be plus maintenance as well.
And that includes training for one user?
Training is generally separate outside of that, and that's something that Ashley or whoever else could obviously, see what would be a good fit for you guys, so.
Does that include the post-processor modification?
Yeah, yep.
And with that is, the different controls that you already have on your Mastercam, it's gonna be able to, give a G code for each one of those controls?
Yes, yep. So technically, if you had like a single license, but 5 different posts, right, you could program each of those machines because we're using a license, a user license, not a per machine license. So, yep. Sorry.
Will that work as like a CMM integrated Mastercam?
So, I don't want to say it's going to replace a CMM, right? Because in my opinion, any error in the machine tool, right, is going to be showing up, perfect, right, in your results that you're measuring. So it's always good to check again with a third-party gauge, and cross-validate things. But the probes, as long as your calibration and indicating in your Ruby, right, they're repeatable, within a few microns, right? So with that being the case, in my opinion, it's good to check it there at the machine before ripping it out and determining, crap, I'm oversized or undersized, whatever it may be. It's also very consistent, right? So we're going at the same, the probe's going at the same feed rates to check things, where maybe one operator, has a little bit different touch and feel, right, as far as that goes. Again, maybe it's a part that needs to be, brought into a granite plate, put a height gauge on. There was actually one I was working with Rob on at a technical conference, and it was just a business card holder, but the back side of that business card holder was pretty thin. And so, again, that would have required me to take it out of the machine, put a height gauge on to find the differences. But with the probe, I was able to align, to the middle of that thin edge, right? Probe in Z on the back side, probe in Z on the front side, do a feature to feature to find the difference in height and give me that data. So I know that, okay, it is within spec before ripping it out, to properly check it and document as well. So, yep. Yes, sir.
So I noticed you have tool setting and breakage.
Yep.
Are you also compatible with Bloom lasers as well?
Yes. Yep. And Bloom is actually an active project that we're working on, in integrating all of their laser systems into the software as well. So, yep.
TNC7, do you support that?
So yes, we do have support for the TNC7. It's actually using the 640 control, just because there were no additions to the TNC7 from the 640. But so everything is backwards compatible in that fact. So yep.
We have, 4, seats of Mastercam.
Okay.
If we buy one of these, we have a network, network license.
Sure.
Can that be used, with any of the,
So as long as it's a networkable license, yes. Yep.
and the training is done at the Anaheim facility?
That would have to be a question for one of the CAD-CAM guys.
It's flexible, it'd be on a case by case basis.
Okay. Yep. Any last questions? Okay, very good. Well, I'll be obvious. Yes, sir. Yeah.
On the tool detection, if the tool broke, sometimes they're so sensitive that when they're dull, the whole machine actually stops, like thinking the tool broke, but it's actually just dull.
Okay.
Does that happen a lot with this system? With the probing?
I mean, we'd have to probably talk about it and see, specifically what or how you're programming it, because obviously there's different inputs that, will tell it tolerances, for either breakage or pull out, as part of that, right? So what's the threshold? So, I mean, if it's dull, are we talking length or diameter, I guess?
Well, just the length, yeah.
On length, yeah, I mean, so there's generally, it knows what the nominal should be, and then based on what it measured, there's usually a tolerance associated to that to say, did it break because we're not, it's measuring too short, or it pulled out, we're measuring too long now. So usually it's just a simple in or out of tolerance, more or less, so.
You started using it, the other question is, I wanna start using it also. You said that, let's say the diameter is small by 2,000 or 3,000.
Mhm.
And it will detect that it's small.
Yep.
Like an ID.
Yep.
Will it automatically, adjust itself on,
Yes.
on the tool,
Ye-
like on the CAD-CAM?
Yeah, so as long as you have the option is enabled, the Renishaw macros do allow for like a T number, right, which is the tool number that needs to be updated. You could also pair that with like an F, which is their feedback percentage. So if it's just the T, it's gonna comp the tool by 100% of the deviation that it found. The F in conjunction with that says, maybe I only wanna update 60% of the deviation found. That way it accommodates for any, maybe backlash or spring passes, right, things like that. Obviously there's a tolerance to work with, right? So instead of going 100% and maybe overshooting it, now you have another problem of scrap part. We can, get it close and, make that adjustment as needed. So, yep.
We're setting it in there, yeah, it's gonna be in there.
Yep, exactly. And then they also allow for like an upper tolerance limit that they call it. So, so there's, the tool number to be updated. That's set to automatic, right? Because it's pulling the tool automatically off of what Op12 is using. If Op12 changes in any way, then it's going to get marked as a dirty tool path. We just simply need to regen, and we're good to go there. But yes, here's where that that feedback percentage, that I have is. There's the upper tolerance limit to say, hey, I don't feel comfortable with changing or updating the tool maybe over 10 thou, right? Because maybe that seems a little excessive. That could be if it mismeasured or a chip on the probe, something like that. It's making these decisions automatically, so that's kind of a threshold, right, if you would, of a check and balance. And then there's times too, maybe we don't want to update the tool, right? So that's where your adjustment tolerance zone is. If it's within 2/10, right, I don't necessarily need to chase the tenths on my tool and keep on updating, part after part. If it's within, again, maybe a couple tenths subject to the part and materials, then maybe I don't care about updating the tool. I only want to update if it's, outside of this area but underneath this area, right, more or less, so. Very good. Unless there's anything else, I will, like I said, I'll be hanging around, obviously. So feel free to catch up or ask any questions as needed. So.